Hello and welcome to today's episode of One Man and His Whiteboard. Today we're going to be talking about IP addresses. In particular, we're going to be talking about the IP address layout and what the different numbers mean in IP addresses. So we're talking specifically about IP addresses where they're represented by a byte, followed by a byte, followed by a byte, followed by a byte. Now these bytes are usually in decimal format. We talk about IP version 4 here. We will talk about IP version 6 in a later video. There's an example of which would be 10.1.2.3. 10.1.2.3. Now a byte can represent from 0 to 255. And 0 is written in binary with 8 zeros. I like to bunch them together in groups of 4 because it just makes them easier for us to understand and digest. And I apologize for doing the digest joke. It is, of course, because half a byte is a nibble. And that really is what it's called. Half a byte, if you think about it, is a nibble. So I like to bunch them together in nibbles, even though they represent 8 bits. I like to represent them as groups of 4 because it's much easier to work with and not miss one off the end if you try to do it with multiple, with 7 numbers or 8 numbers or something. It's easier to make a mistake. So all IP addresses follow this format, and it's quite simple. It's all to do with the bit representation of the leftmost bit of the first byte. So expanding this first byte out, you'll see that we have effectively the opportunity to have 8 bits. I'll draw a little space in the middle to group them together in nibbles, as I mentioned, because it's easier to work with. If this leftmost bit start moving from the left towards the right, if the leftmost bit is a 0, that is what is known as a class A IP address. If the leftmost bit is a 1 and the next bit is a 0, that is a class B. If the leftmost bit is a 1, the next bit is a 1, and then we have a 0, that is what is known as a class C. If the leftmost bit is a 1, then another 1, then another 1, then a 0, that is what is known as a class D. And finally, if we have 4 1s in the leftmost 4 bits, that is known as a class E. Now, that means that A goes from 8 zeros to 0 followed by 7 zeros. So the possible numbers we have here are 8 zeros through, I kind of messed up that last 0 there, I apologize. I am drawing these with my mouse, so please bear with me. So it goes from 8 zeros through to 0 followed by 7 1s. Then a class B address goes from 1 followed by 7 zeros through to 1 0 followed by all 1s, and that of course will be 6 1s. A class C address goes from 1 1 0 0, all followed by zeros, right the way through to 1 1 0 followed by 5 1s. So 0 followed by 7 ones, 1 0 followed by 6 ones, or 1 1 0 followed by 5 ones. And if you convert these numbers to decimal, you see very quickly that a Class A address is always in the range 0 to 127. A Class B address is always in the range 128 to 191. Class C address will always be in the range 192 up to 223. And I won't draw any more binary here because D and E are very specialist anyway. But I'll just say that D, if you follow the maths, is from 224 up to 239. And E is from 240 up to 255. I'm feeling guilty now. E is very unimportant, but D is actually quite important. And there may be internet people calling me as I speak because I said E is very unimportant. What I mean, to the average user, E is very unimportant. Of course, to someone somewhere, it's very special. So I'm going to draw this in just to be exacting. Because D, as you'll find out in a minute, is actually very, very important. Okay, so Class A, B, and C are IP addresses. Class D is what is known as multicast. And we have an entire one man and his whiteboard session on multicasting. What I'll say for now is unicast is when A send, well, I was going to say A sends a packet to B, but I just realized that's probably not the best explanation. So Alan wants to send a packet to Bob. Alan will send a packet or a frame to Bob. That is what is known as unicast. Alan wants to send a frame or a packet to everybody in the room. He will broadcast. Everybody on the network gets it. What if Alan only wants to send it to all the men who are wearing a blue t-shirt or all the women who are wearing an orange t-shirt? Well, that's what multicasting is. And for multicasting to work, you actually have to join the group. Just wearing the orange t-shirt isn't good enough. You have to declare, hey, I'm a woman, I'm wearing an orange t-shirt. Hey, I'm a man, I'm wearing a blue t-shirt. Hey, I'm a man and my name starts with a P and I'm wearing a blue t-shirt. You can become that selective. You can say, I want to send it to a particular group of people in the room. I want to send it to a particular group of nodes on the network. But every node must have joined the group. That's a key point to understand. Okay. So anybody can create a group using any of the addresses in the multicast range. And we'll leave that till a later time. So A through C are standard IP addresses, and E is reserved. E is reserved for the Internet Authority to do what they want to with it. They can do testing or they can do whatever they want to. So E is reserved, which is why I said it's unimportant to most of us in the day-to-day. So now we understand what class of address an IP address is. And you can see by looking at the first number of the IP address whether it's Class A, Class B, Class C, or something else. And it's very important to understand what class an IP address is, because the class of the IP address defines some very important properties about the IP address. Now, before I go into that, I will introduce you to one other concept you have to be aware of, and that is the concept of reservation. The address 0 is reserved. I seem to have a little floating purple 1 there for some reason. Let me get rid of that. The address of 0000 is reserved. So that IP address is not allowed. the address of 255, 255, 255, and 255 is a broadcast address. That is also not allowed. So that is reserved, that is reserved. A long time ago, they picked one number to mean home or the loopback. The loopback means my address. And they basically picked 127, which in hindsight was a bad number to pick, but never mind. So 127 can't be used. Well, 127001 is what is known as the loopback. It's me. So whenever you ping 127.0.0.1, you're pinging yourself. You're testing if your network has functionality. That is also reserved. And what they did was they kind of went, you know what, let's reserve everything on 127. So 127 is normally totally reserved. So even though we have all these IP addresses, there are restrictions what we can use. So hopefully now we understand that by looking at an IP address first byte, the first number, you can tell what class it is. Now class is very important. Class is very important because the class of the IP address defines how the IP address is broken down. So a class A is broken down, so the first number is the network, then the next three groups of numbers represent a host. And for now, think of the network as your street address. And think of the host as your house number. We could, of course, try to be clever here and use N for neighborhood, your street or your neighborhood. Okay. H for house. Actually, I'm just thinking dynamically here. That would be great for fitting in a subject we're talking about later with subnets. But we'll stick with this for now as a street or a neighborhood. So as here you can see, we have one street with lots of houses on. We have 256 times 256 times 256 houses. Now for the purists amongst you, please understand that all zeros and all ones are not allowed in any address. There are rules that change this based on the vendor specifications, but as a very basic introduction to networking with binary, avoid all zeros and all ones in any field. So all zeros in the network field or all zeros in the host field is not allowed to be given as a real address. All ones in the network field or all ones in the host field is not allowed to be given as a real network address. So you always subtract 2 at the end. You always minus 2. So here we have 256 networks. Well, no, because the class A address only goes from 0 to 127. So you go from 0 to 127. But you're not allowed to have 0, you're not allowed to have 127, so it ends up being 1 to 126. You have 126 networks. And then you have 256 multiplied by 256 multiplied by 256 minus 2 hosts. And I'm not even going to do that calculation. That's homework for you. Get a calculator, work that out. Okay. A class B address has the format of network, host, host. Now in the network field, it's going to have, and I'm starting to think about this now, it is going to have from 128 through 191, which is 64. Because the B network can only be from 128 through 191. So 64 times 256 networks And hosts will be 256 times 256. Minus 2, because you can't have all zeros, you can't have all ones. And a class C address will have network, network, network with host stuck on the end. So a class C address will have, here's where my maths, you haven't got to be great at maths to be a network engineer, you just got to own a calculator, right? That will be from 192 to 223, which will be 32 times 256 times 256. Networks, as you can see, that's a lot. And then 256 minus 2 hosts. So the idea here was, rather than have a linear network and host, street and house number, if you had a class A network address, you'd have a small number of class A networks with lots of hosts on them. Think large corporations. B would be a mix, 50-50 kind of. And C, lots of networks with a small number of hosts. Think small companies or your house. Okay, think small number of hosts, think huge number of hosts, think in the middle. Now, to signify that a field is a network or a field is a host, we put a 1 in the bit position if it's a network, and we put a 0 in the bit position if it's a host. Zero for host, 1 for network. I tried to clean that up, but I think I ended up making it worse. Or worse, even. I think you only make it worst if you're German and you involve German sausages. I apologize for the very terrible worst joke there. All right. So if we have all ones, 8 ones, remember 8 zeros is 0, 8 ones is 255. So then we signify using the network mask that there's all ones in the first byte, which is 255, followed by zeros for a class A network. Well, remember, all zeros, apologies guys, I seem to have lost signal between my mouse. There you go. That is, of course, 0. Whereas 8 ones represents 255. A class B would be 255.255. Try to really emphasize the dot there. Dot 0, dot 0. And a class C address would be 255.255.255. So you put a 1 in the field that has the network. So there's 3 network fields, so 3 lots of 255. And I'm trying to be as on best behavior as I can, and I don't want that to look like anything weird, like a 6 or anything. So I'm going to redraw a few parts of this. I am actually using a thumb mouse here, so I amaze myself that I can actually draw numbers at all and letters on some days. There you go. Now another way of representing this, we know that 255 can be represented as 8 ones. So another way of representing the network mask is to put a slash in and then count the number of ones in the mask. So an A network mask will be /8. B will be 2 lots of 8, which is /16. And C is 3 lots of 8, which is quite simply /24. So understanding the class of the network is very important, because once we understand the class, we can look at the basic numbering scheme and understand the default mask. Now I just want to go one little step further on this. The Engineering, what a great name, the Engineering Task Force. Maybe I should copyright that. The Internet Engineering Task Force has decided to give us, in each of the ranges, networks that are what are known as private. So anyone can use these network ranges safely without interfering with anybody else. And in a Class A network, we have 10, anything on 10, 0, 0, 0. In a Class B, it's 172.16 through 172.31. So anything in this range is a Class B network address that anybody can use. And the Class C is 192.168. So remember, the default Class A is 8, the default Class B is 16, the default Class C is 24 bits of network mask. Well, what they did, they said anything where the first 8 bytes match 10, here anywhere where the first 12 bytes matches within this range, anything within 172.16 through 172.31, and then anything where the first 16 bytes match 192.168 are Class A, B, or C networks that anyone can use for whatever purpose they want to. Now within these ranges, there may be other reserved ranges. For example, I'm just mentioning this now because if you're going to get into wireless, you need to know about this. So the 192.0.2 network is also reserved for what is known as documentation. There's a couple of others as well. There's a 198 and a 203 network. Just look them up. Google Internet Reservation Documentation, Class C networks. This is one of the most important ones because you might see this a lot. If you connect to a Cisco wireless LAN controller, you may see that the virtual IP address of the controller is 192.0.2. something. So it's in the Class C range, but it is also a reserved address. So there are various reserved addresses outside of the scope of these private address ranges. Okay, so in summary, we now know how to identify the class of an IP address based on the first byte, the first number. Once we've identified the class of an IP address, we know how to calculate its default format or layout with respect to the network portion and the host portion. And we also know that there are reserved numbers some reserved for private addressing. So you might recognize if you are home or you're in the office, if you look at your IP address on the machine you're using, you might very well see that it's in the address range 10 or 172. something, 16 through 31, or 192.168. something. That just simply means that your company is taking advantage of the private address ranges and keeping them exclusive inside your network, so you use these addresses. Now, you may find you have a different IP address, which is good for you. That means you may actually have a real IP address. It doesn't mean you don't have connectivity if you use one of these private addresses. We have a little bit of magic that goes on at the router at the edge called network address translation, and it is the job of the edge router, normally the one that plugs into your service provider. It is that router's job to convert the internal addressing to real outside addressing, but that's a conversation for another day. Okay, that's the end of our session today on IP addressing with one man and his whiteboard. I trust you had fun, and we'll see you next time.